So Kevin, we're in the inner sanctum here of the Slipher Building, and you're going to be talking to us about glass plates. Why are they so important?
Well, you know, today we live in a digital age, and we're used to taking lots of pictures on the camera. We look at a chip and we can see zillions of pictures. In the old days, they took pictures with cameras. And when we think of cameras, we think of maybe 20 or 30 years ago when you had to load film and such. Even before that time, astronomers used glass plates. So a glass plate, and this maybe 14 by 17 inches or 8 by 10, those each served as one piece of film. That's how they would take pictures. So, you know, today we have hundreds or thousands of pictures stored in our little phone. Mm-hmm. In here, we have thousands of them stored, and there are all these glass plates that line the walls.
Wow.
So it's a really neat place in here. I think of any room at the observatory, this is maybe one of the most interesting, because you think of these hundreds, thousands of plates and the man hours and the careers that are represented in here. And we go in this room and there are several different careers represented. And you think of the thousands of hours of time, and that stuff was not only important for making discoveries then, we can still use it today, but we need to digitize it and make it useful for modern research.
And I'm curious, when somebody was doing observing and taking the pictures, how many images did, or astrographs, I guess they're called, did they take in a viewing?
It depended on what they're looking at, but when they were searching for Pluto, they would typically do exposures of an hour. So they would take a picture of a specific place, do that exposure for an hour, and then take another image of another place. So they could do, in that case, several of them. But then there's people like V.M. Slipher, who is looking at what we know as galaxies, and he was doing exposures over dozens of hours. And so he would set it up, track the telescope all night. When the object was out of view, it is set, he would close the telescope down, move it back, and the next night when that object came up, open the shutter again and continue the exposure. And this was not easy. It was groundbreaking work. And so preserving this stuff is critical, because this is some of the first that it was ever done that way. And they made those discoveries, but you know, with better technology to analyze glass plates, for instance, we can find new things and really supplement research we know about, and there's a lot of great benefit to it.
And if you think of people who made amazing discoveries examining glass plates, like Henrietta Swan Leavitt, who figured out the time of, light years.
Yeah, Pickering's computers, females, they laid the groundwork for so much work, and without those plates, they wouldn't have been able to do any of it. Let's go inside.
Yeah, let's go inside.
And you got to breathe deeply. I wish you could capture this over the camera.
Can everybody on Facebook smell the?
Well, it is.
Smell of history.
It's like when you go in a used bookstore and you can't help but smell deeply. That's what it is in here. And look at all these thousands of plates. We have about 35 to 40,000 of these plates. Not all of them are in here, but this room represents the plates starting with in 1905, when Percival Lowell began searching for what he called Planet X, which eventually led to the discovery of Pluto in 1930. So down in the far end are some of those early plates that are now 115 years old. And then these are a lot of the ones that Clyde Tombaugh took. And I'm not going to pull this one all the way out, but I know exactly where to look for it. This is one of the Pluto discovery plates. The other is currently on display at the Smithsonian.
So it looks like you've taken the original sleeve and attached it onto the archival acid-free sleeve.
And that's a step in preserving this stuff. The next step with this is moving it to our archive building, because if you look at the floor here, you can see through the years there's been a lot of water damage, and water doesn't mix well with stuff like that.
No.
And so we want to.
This morning we visited with Lauren in the repository, and we saw the state-of-the-art building, and she did talk to us about how donors help to fund rehousing the plates into their archival sleeves. But I guess the next step is to
we want to scan them. We want to digitize them so that modern scientists can use them practically. Once you digitize them, you can access this all in the computer. But think of and then you look at the thousands of hours represented here. The last thing you want to do is drop one, and you've lost that history. And so we want to scan these one by one, and then systematically move them over to the collection center for their permanent storage. And that's a major project because just scanning it is major, then moving these things, it's not like you've got to put a bunch in your backpack and carry them over.
And you only want to handle them once.
Yes, exactly, yeah. So this room really represents, I think, one of the really great identities of Lowell Observatory. We were founded to do research and to share the results of that research with the public. We've been doing it so long that we have these great collections of archives, these tools that the astronomers use to do their research, which we don't use this anymore, this sort of thing. We have computers to do all this. But we want to make sure this is preserved so that future generations understand the heritage of how science is done. And then especially with these plates, these things are still used. 50, 100 years later, they're still quite usable because they're snapshots of what the sky looked like at a particular time.
Oh, so you can take the historical information to help you to make predictions about the trajectory of a celestial object.
Right, and not these particular plates, but there are some others in our collections that when the New Horizons mission was flying out to Pluto, your Pluto is pretty small, and you have this thing moving at 30,000 whatever miles per hour. You want to get the position of Pluto as exact as possible. So one of the astronomers up at the Southwest Research Institute, Mark Bowie, who used to work here, he got a hold of some of the glass plates that one of our astronomers, Carl Lamplin, took after they discovered Pluto. And he digitized them and he analyzed them, and using those from 85 years ago or whatever it was at the time, they were able to refine the orbit of New Horizons a little bit.
Wow.
Because they got a more precise location of Pluto, and that helped them be even more precise with the spacecraft. So these plates are still quite usable.
One of our astronomers here, Stephen Levine, said to me when we were talking about the vision of being able to digitize all of the information that's on the glass plates and get that up available to researchers and the public on our website. And I said, what do you think people might be able to discover? And he said, we can't even imagine yet what somebody will be able to discover when they look at this information. Yeah. And so that really touched me, that some fresh set of eyes maybe is going to see something that we haven't even imagined yet. So.
And what they're doing is really walking in the steps of people like Clyde Tombaugh, who discovered Pluto. They had searched for it for years here off and on with different programs. And here comes this 24-year-old kid, self-trained astronomy. He learned it on the farm in Kansas and in Illinois. And he comes out here and he has the patience and dedication to, night after night, take pictures and then analyze those pictures and look at them very closely and make this discovery. I'm picking out, I hate to use the word literal because it's a little overused, but literally, it was picking one dot out of sometimes hundreds of thousands. He would take these plates about 14 by 17 inches and then wait a few days and take another plate of the same area of the sky, and then using a machine called a blink comparator that has a microscope eyepiece, you look at one small section of this plate, then it flips over to the same small section, and you're looking at every single dot
the dedication.
To see if it's changed position. And it really is just a dot. And yet, he was able to make this discovery. And there's so much great story with it because Percival Lowell went to his grave not finding what he called Planet X. Little did he know that his staff had actually photographed it. But it was a fuzzy image. Not till after the discovery they went back and realized, my gosh, they actually photographed it.
That is so cool. Well, speaking of history, I heard that Lowell is celebrating a very important anniversary this year.
This is almost a quirky year because there are a lot of anniversaries. It's been 175 years since John Wesley Powell went down the Grand Canyon, went down the Colorado River. 150 years. Do I have that right? No, it's 150 years since then. 125 years since Lowell Observatory was founded, which is the first scientific institution in Flagstaff, which says something because we're Science Central here. We have just all these great resources, and we have the oldest science festival in the Western Hemisphere, because not only do we have the resources, we have the scientists who use those resources and study them, and then we have a community that celebrates this.
Right.
And so we have this festival. And then this is also the 50th anniversary of the first moon landing. And so for Lowell, we're kind of tied into a lot of that, where, you know, for us, the anniversary, it's a chance to look back and see at some of the great landmark discoveries, but also an opportunity to look forward.
Yeah.
That's what's really exciting. What are we going to be talking about in 125 years? Another 125 years. What discoveries will the Discovery Channel telescope make? Mm-hmm. And this new instrument on the DCT, Discovery Channel Telescope, called Express, that together with that telescope can see planets around other stars the size of Earth. And it's, you know, when you think about that, you go out on a dark night, you can maybe see a couple thousand stars. Those are all suns. Mm-hmm. And, you know, our sun is kind of Joe average. Some are smaller, some are larger, but you think you're looking for something 1,000,000 times smaller than that point of light.
Wow.
You know, you could fit about 1,000,000 Earths inside of the sun. So you're looking at for something 1,000,000 times smaller. And we have the technology to do that.
Incredible.
So who knows what the future is going to hold.
There we go. Well, happy 125th anniversary, and we'll look forward to hearing more about celebrations that are coming up this year.